On the hardware side, the schematic and PCB layout designs have been completed, with a focus on optimizing power integrity, anti-interference capabilities, and structural layout. Simultaneously, the outer shell structure is designed and manufactured to achieve consistency in strength, heat dissipation, and assembly. On the software side, progress is being made simultaneously. Underlying drivers, sampling links, time synchronization, state management, and communication software, such as UART, SPI, CAN, or RS-485. To facilitate faster customer integration, we also provide host computer software for parameter configuration, data visualization, logging, and exporting. Next, we'll visit the factory to see our production process. We assemble and control the consistency of the hardware, firmware, and structural components, completing the solidification and traceability management of key processes to ensure that every device is stable and reproducible.
This is a single track welding furnace for MEMS production. This is an AOI automatic inspection machine for MEMS inspection. This is an automatic soldering machine.
This step determines how well the device performs. We perform calibration for zero bias, scale factor, inter-axis non-orthogonality, and installation errors, and implement temperature compensation and long-term drift control to ensure that the IMU outputs stable and reliable data in different environments.
Micromagic welcomes you to our factory tour. This is our environmental and reliability testing facility. First, we have the high and low temperature testing area. The temperature chambers you see are conducting constant temperature testing and temperature cycling tests, operated by engineers on site to ensure product performance remains stable under different temperatures. Here are our quartz stabilization platform and 9-axis turntable. We also have a 9-axis turntable with a temperature chamber, a large external temperature chamber enclosing a smaller turntable, allowing for multi-axis attitude and performance testing in a controlled temperature environment. Finally, we have our vibration table, used to verify the structural reliability of the gyroscopes. During testing, the gyroscope is vibrated at specified frequencies, amplitudes, directions, and durations to evaluate whether the structural design, materials, and assembly process can withstand the vibration stress during use.